We rarely think about the ground below our feet. In New York, the ground is the sidewalk, mostly. However, there are billions of years of geologic history that lie beneath the sidewalk, beneath the subway and the gas and electric pipes, beneath our skyscrapers and our parks. The deepest layer is the bedrock. The oldest exposures of Precambrian rock in the New York region are estimated to be 1.3 billion years old. Called the Manhattan Prong for its shape, this ancient rock and our landscape was produced largely by the erosion of river valleys between periods of glaciation. Much of the modern landscape in Manhattan and the Bronx is only a thin veneer of soil that developed after the most recent episode of glaciation. Large glacial erratics, or glacially transported boulders, and glacial till, silt, and sand filled in the land and blocked and altered the flow of rivers and oceans. Valleys filled with sediment and left New York with a great deal of gneiss, schist, and marble. Gneiss, a metamorphic rock that has distinct banding, is easily identified in places like Central Park, where rock is exposed. The influence of weathering on the landscape is perhaps best illustrated by the path of the Hudson River along the western edge of Manhattan and the Bronx. The Hudson River, the Northern Hemisphere's southernmost fjord, follows the boundary between the crystalline basement rocks of Manhattan and the younger westward-dipping sedimentary and volcanic strata of New Jersey. Rock shaped more than just the island of Manhattan. It shaped how we use and develop it, from rat rock on Columbia's campus that is too big to move, to the shape of our parks. The rocks help to define the borders of the parks, claims Jed Lackritz, a historian at the City Department of Parks and Recreation. If land was rocky, it wasn't usable for commercial development. Rock composition also shaped the one train, New York's first subway line. The rock's dense composition and a fault line in the area would not allow deeper construction, so the subway emerges from the ground at 125th Street and crosses the Manhattan Valley on a viaduct instead of underground. Bedrock determined the height of buildings in New York. Skyscrapers were erected on bedrock to give them solid foundation. The natural landscape has shaped our city in many ways we might not think about. In fact, most of the stone from which New York's brownstones were built comes from the New Jersey sandstone that was still mud when dinosaurs roamed the marshes. If you look closely at the buildings of New York, you might find fossils of trilobites, a dinosaur footprint in stone built into a New Jersey courthouse, Missouri brachiopods in the Brooklyn Municipal Building, or Cretaceous clams in the downtown Western Union. You can stand on the 40th floor of the Empire State Building and not know why it was built there instead of in Union Square or Alphabet City. You can sit in the sun on a rock in Central Park without knowing that it is glaciated Hudson schist. Yet these facts help determine the layout of our city. The glaciers of old would marvel at our pace and our frenetic movement across this tiny island.